Multi-dimensional visualization is even more interesting than what we looked at previously, because life turns out happens in more than one or two dimensions. And so what we have here for the first type of plot is a scatter plot, same thing we saw previously, but now instead of just two variables represented, we have three variables, where we have NOx and the y-axis, LSTAT on the x-axis, and then the color tells us whether we have a high or a low median value according to this categorical median value variable. Another useful variation on this is something called a scatter plot matrix, where we still have NOx on the y-axis, LSTAT on the x-axis, but then we're going to break the data down by the variable rad, R-A-D, and then we still have whether it's a low or high median value. So you notice wherever rad is 1, we have this sub-data set, you might call it, which is much smaller than when rad is 7. And we see that there are 1, 2, 3, 4, 5, 6, 7, 8, and then 24. So there's 9 total values that rad can take on. So we're really looking at 4 variables here, and this is a one way to do that graphically. Although typically, even if you were to look at just 3 variables in a 3-dimensional plot, that's very difficult to do, and in 4 variables in a 4-dimensional plot is impossible to do. Here's another example of a scatter plot matrix. This one is not breaking it down into particular values for another variable. Instead, we have the crime variable, indus, LSTAT, and median value. And median value in this row is always on the x-axis. Median value in this column is always on, sorry, I got that backwards, always on the y-axis here. Median value in this column is always on the x-axis. So if I want to know see the scatter plot between crime and median value, it's going to be crime on the y-axis, median value on the x-axis. Here it is. Indus and LSTAT looks like that. So again, another good summary, graphical summary for looking at variables and seeing what kind of relationships you have here. So these two things are actually mirror images of each other, and that's true for the upper triangle and the lower triangle. One of the things that we can determine very quickly from looking at this scatter plot is when we need to make a transformation. And here we've got crime versus the median value on the original scale. You see it kind of bunches down here. It's this lower 0 value. And if we take the log of this, this looks more like a linear relationship than a nonlinear relationship. And you can see the same thing here. On the original scale, we've got the categorical median value and crime rate on the y-axis. You can see there's a bunch of crowding down here and here, and if we take the log, then we get things that look more spread out and would be more conducive to the statistical methods that we've learned in Stat 601. One thing that graphs are good for is aggregation of data. Here's an example. With our Amtrak ridership data, we have this time series, and you can see that there's a trend that goes through it right there. And if we wanted to say, well, how does this stuff aggregate monthly, we could go through and say every time there's a January, let's compute the average. So here, January average is going to be here, February is down here, March, April, May, June, and so forth. And so we can see when we get to December, we're going to start, we could connect this and keep it going if we wanted. But this basically just goes through and averages monthly. So this helps us understand in the summertime, there's more ridership than in the wintertime, it looks like. We can aggregate monthly, we can also aggregate yearly and go through and say, let's look at the yearly average. So starting here and just go average over 1991, 92, and so forth. we can see, oh, 1996 there was a trend. So this tells us the seasonal cyclic pattern. This tells us what the trend is like. And if you were to take a time series course, you learn much more about this, but we're not going to do that in this class, although there is a chapter in the book that you can look at if you like. Here is another scatter plot. This time we have the labels. This is a utilities data set, and it's oftentimes helpful to be able to see the labels. Here's another scatter plot where we have something called jittering going on. There's a lot going on here, actually. We have personal loan data, yes or no. Income is X. Credit card average is Y. And when we say jitter, what we mean is we're going to just take the data point and add a little bit of noise in the X and Y so that all the data points that would otherwise be sitting on top of each other can be seen. Parallel coordinate plots are very useful, and they give us a look at the data that we don't otherwise get to see sometimes. In the week 2 folder, there's a little handout on parallel coordinate plots. You should look at that. But basically what it does, it says when we have 0 or a 1 for categorical median value, we have these two separate data sets, and if we plot the crime rate, for example, for all of the data, we see that there's a whole bunch of crimes being committed, or rather a whole bunch of these neighborhoods have very low crime rates. There's a few with high crime rates. If we come over here to the more expensive courthouses, we see that the crime rates are much lower, and maybe that's because they have security, and who knows what the reason for that is. But then we can go on to zoning and say what's going on in zoning. Zoning is 0, or is the size of the lot, I believe, and so we see there's a whole bunch here. It's kind of scattered out up here. In zoning, there's a bunch. The majority of the houses are larger. Sorry, for those houses on the Charles River. The number of rooms in the house for the houses not on the Charles River, you can see that's lower than those on the Charles River. So not only can you see the levels, but you can see the amount of variation. Elstat, for example, the non-Charles River versus the Charles River, these are all much more tight around some value, whereas there's much more variation here. So check out that handout. It will be very helpful for you. That is the handout that's in the week 2 folder, if you don't understand what's going on with these parallel coordinate plots yet. Another popular thing anymore is this notion of a dashboard and linked plots. So if we have a data set and we want to look at several different types of plots, we can have these things all linked up together. So you could say, where is this data point, for example, and you could highlight it and it will show up wherever it turns out to be. Turns out to be over here, and I don't know which one it is, but let's just say it's that one. It should also show up somewhere over here as well. So what's going on here is someone said, well, let's look at all of this data right here, and it happens to show up right there, and here, and here, and whatever the highlighted stuff is. Network graphs are depicted by, or rather are used to depict relationships in a network. Think of this as like a social network, or in this case we're looking at eBay, and over here we've got, I think this is sellers on the left and buyers on the right. So this person here sold to all of these people, and everywhere there's a red line going over there. And the size of the circle says how many transactions they've done. The width of the line says how many transactions were done between the pair. So here you've got a big solid red line going between this one and this one. They both have entered into a lot of transactions, and apparently a lot of those have been with each other. Tree maps are very useful. We looked at one in the last video just briefly, but the idea here is you can add multiple measures. Here we've got the size of the rectangle is the average closing price. Looks like we're talking about items sold on eBay. So we've got the Rolex watches, Cartier watches, vases, some sort of telescope, and golf balls, and so forth. And the percentage is depicted by the color. So the darker the color, the higher the number of sellers that have the percentage of sellers with negative feedback. So Rolex watches are expensive, and the sellers generally get a lot of bad feedback. And finally, we have a graphical map. In this case, the map of the world, and we have different measures that go by country. You could have maybe a region, a state with counties, or something like that. And the darkness or the shade tells you the level of the variable that you're interested in. So that's what I've got for this video. We will see you guys in the next one.